Good day to you. This is teacher Leland, Alejandro, and we're going to study today how to find angle measures of right triangles. So this will be our lesson for this discussion, and we're going to see the problem set on the other screen. So this is finding the angle measure in the right triangles. So let us see the problem set. Okay, let us begin with the first number, and let's see how many we're going to do here. Okay, so we have about 10 numbers. Okay, 10 numbers. So this is solving for angle measures of right triangles. Solving for angle measures of right triangles. So before we begin the solution, let us have a little bit of the concept. Okay, so we shall begin with right triangle, then study some concepts about it. So let me draw our right triangle here. Okay, let's consider this right triangle with right angle over here. Okay, and this is the mark. And of course, this will have to be the 90 degrees. This will be the 90 degrees. Okay, all right. Let's mark this acute angle over here, the angle A. And let's mark this angle over here, the angle B. And then the 90-degree angle of this right triangle be marked capital angle C. So capital letters for the angles. All right, let us denote the sides opposite to the corresponding angles marked with small letters. So angle A will be opposite side over here. This is small a. And then opposite side to angle B will be marked small b. And of course, the longest side in the right triangle, the hypotenuse, is opposite the right angle. So we'll denote it by the small letter C there. So the angle and its opposite side is paired, and of course the angle will carry the capital letter and the opposite side will carry the small letter. So this is angle A. This is angle A over here. Okay, and opposite side to this is this side. Okay, there. So this is angle A, and this is the opposite side, small letter A. Okay, also angle C, which is 90. Okay, opposite the angle 90 is the hypotenuse there, the longest side, which is denoted by the small letter C. And of course, the angle B is over here. Opposite side to angle B is the side here, there. So denoted by the small letter B. Okay, so what we're going to consider is the three trigonometric functions first. So considering the sine function, the sine function is the ratio of the opposite side, to the hypotenuse, there. And then cosine function is the ratio of the adjacent side, adjacent side to the hypotenuse, there. And then we have the third, which is tangent. The tangent ratio is opposite side to adjacent side. So it's opposite side to adjacent side, there. So this is what we need to memorize, okay? All right, sine is opposite side divided by hypotenuse, okay? The ratio of opposite to the hypotenuse, that's sine function. And then next is cosine function, that's the ratio of adjacent side to the angle divided by the hypotenuse. And then of course the third, tangent function, this is the ratio of opposite side to the adjacent side, okay? So of course, this all depends on which angle you are considering, okay? Now there are two acute angles here. Okay, there are two. So one is the angle A, this angle. Okay, and the other acute angle is angle B. Okay, this angle here. So if we consider angle A, we will start with angle A. So we will have sine of A. It's abbreviated this way. Sine of A will be the ratio of opposite side to angle A. Opposite side to angle A. So that means it's a ratio of the small a to the hypotenuse. So that's the C there. And then cosine of A, that's the ratio of the adjacent side to angle A. That's the side B. Okay, that's the adjacent side to angle A. Now that will be B over C. Okay, the ratio of the adjacent side to angle A to the hypotenuse. Now the tangent of the angle A will be the ratio of the opposite side to the adjacent side. So that is opposite side A over side B, okay, which is the adjacent side. So this is the tangent function of angle A. This is if we're going to consider angle A. Now considering angle B, this time we will have a different orientation. For angle B, the opposite side B will be considered, okay, divided by the hypotenuse. So this time for sine B, it will be the side B, ratio side B to C, there, opposite divided by hypotenuse. And then for cosine of B, we have cosine of B. This will now be the ratio of adjacent side to angle B, and that is A divided by the hypotenuse C. That's adjacent over hypotenuse. And then we have the tangent of angle B will still be opposite over adjacent, but the opposite side is the small b, and the adjacent side is the side A there. So it really depends on which angle you are going to consider there. Okay, so we shall make use of these formulas, and just remember you have to memorize the meanings of the function. Okay, memorize this. You have to memorize this concept here. Sine is opposite side over hypotenuse. Cosine is adjacent side to the hypotenuse. And tangent is opposite side over adjacent. Okay? And then you only need to figure out which angle you are considering. Okay, so memorize this concept and memorize the drawing, but you don't have to memorize the letters. Okay, you just have to determine or identify the side opposite to that angle, and adjacent side to that angle. Hypotenuse will always be opposite the 90 degrees. Okay, all right, so let's make use of these formulas and determine the answer for the first number. So let me erase this, and we will now proceed to number 1. Okay, the instruction is to find the measure of the indicated angle to the nearest degree. Okay, so first we have to identify which angle we are going to solve. For this particular diagram, the one with the question mark. So let us just denote it with X, okay? So we will be solving for angle X here, there, okay? All right, so using that angle X, what is the side with a 45 measure and with a 48 measure? Now, notice that the 48 is opposite the 90-degree angle. So that means the 48 is hypotenuse, and the 45 is opposite the angle with a question mark. Okay, when we say opposite, it's this, there, like that. All right, and then this is the 90 degrees, 48 is the opposite side, there. Okay, so remember, if you have this angle, the opposite side is the one that closes the figure. This is the opposite side. Okay, if you're going to consider this angle here, if you're going to consider this angle, then the side opposite is the side that will close the angle to a triangle. There, that's the opposite side. Okay, all right, and so we're quite sure about what we're talking about there. Okay, the 90 degrees opposite side to that is the 48, and then the the one we marked x, this angle here, opposite side to that is the 45. Okay, so we have the 48 hypotenuse. So we have here opposite side and hypotenuse, and we can only determine the angle by means of the sine ratio. So our solution will be using the sine ratio. All right, so let us solve it. So we have sine of x that is equal to the ratio of 45 over 48. There. And so we will have to consider inverse sine. This will be arc sine of the sine is equal to arc sine of the 45 over 48. There. And notice this will cancel each other, the sine and the arc sine. Okay, and so the next line we will only have x. This is equal to arc sine of 45 over 48. And you can use your calculator to find the answer. Okay, make sure it's a scientific calculator. So this will be arc sine of 45 over 48. The answer is 69.6358. 6519. Yeah. Okay, according to the instruction, round it to the nearest degree. So 69.6 is 70. This is 70 degrees. There. And this is our answer. Let's verify from the computer. Okay, so it's correct. All right. You can see the answer over here. And that goes to our first number. Let's continue with the second. Okay, we proceed to number 2. Here's the next figure, and we shall mark this x, our unknown angle x. Okay, now what we have here is the opposite side 19 and the hypotenuse 54, the side opposite to the 90. Okay, so we can use again the sine function. So for our solution, we will use the sine function. Sine x is equal to the ratio 19 over 54. There. And then we continue taking the arc sine or inverse sine of both sides. So this will be arc sine of the ratio 19 to 54. There. And this we have x is equal to arc sine of 1954. And so x is equal to, okay, we make use of our calculator. This will be inverse sine of 19 over 54. If you have a trigonometric table, that will be useful also. But the scientific calculator is a lot more accurate. Okay? All right. So we have here 20.600,624.55 degrees there. And we shall round this to 21 degrees. Let's insert the equal sign there. So we have here 21 degrees. Let's verify from the computer. Yes, it's 21 degrees over here. Okay, let's proceed to number 3. Let me clear our solution. Let's continue with number 3. Okay, find the measure of the indicated angle to the nearest degree. Okay, observe the diagram. The angle in question mark there, all right, with a question mark will be marked X. So we'll put a label here, say X, okay? All right. Now, what we have here is the side opposite to the angle X, that's the 46. And of course, opposite the 90-degree angle, we have the 48. So what we have is opposite and hypotenuse. So again, this will now be our solution. Sine of X is equal to opposite side 46 over 48. There, okay? And we will take the inverse function of both sides, and this will be arc sine of 46 over 48. There. Next, we have here X is equal to arc sine of 46 to 48. And that's it. We will be able to get the value of the angle. This will be inverse sine of the ratio 46 to 48, and that should be about 73.4. Let's complete all the digits. That'll be 5786. This will be in degrees. And angle X is rounded to the nearest degree. This will just be 73. There. That's it. This is our answer. I think I've erased it. All right, there. So I'm trying to encircle it. Okay, I'm trying to enclose it. So there. Okay, 73 degrees. Let's verify from the computer. 73. Okay. There. Okay. All right. So let's continue with number 4. Let us clear the screen. Let's continue with number 4. Okay, here's number 4. All right. Find the measure of the indicated angle to the nearest degree. All right. The angle we have here is over here, and this will be marked X. Okay, what do we have for sides? We have the number 22, the 22 units. All right. This is a unit of length. That is considering the angle X. That's the adjacent side. And the 36 is the side opposite the 90-degree angle. So what we have here is adjacent and hypotenuse. So adjacent divided by hypotenuse, that will be the cosine function. So we will solve this by way of cosine function. So this is cosine of angle X. That's equal to the ratio 22 over 36. There. And then this will now be arc cosine, okay, arc cosine of cosine X is equal to arc cosine of 22 over 36. And we have here X. This will be arc cosine of 22 over 36. So we will use inverse cosine to find the answer. So this will now be inverse cosine, and that's 22 over 36. All right, we have something like 52.33. 0.011304. And this will be in degrees. Next, we will round it to the nearest degree. So our angle X is just 52 degrees. There. And so this will now be verified by the computer's answer. Yes, it's 52 degrees. Okay, let's continue with number 5. Let's continue with number 5. Here is number 5. Find the measure of the indicated angle to the nearest degree. Okay, again, examining the diagram, we have this as the angle X. And then what we have here is the hypotenuse 48 and the adjacent side 45. Okay, we don't have the opposite side of the question mark angle. Okay, all right, so that means we have adjacent and hypotenuse. That suggests a cosine function. Okay, so our solution depends on what we have. Okay, and so we have the adjacent side 45, adjacent to the angle X, and hypotenuse 48. So we can use the cosine function here. So in our solution, we will use the cosine, and this will be a cosine X. This will be 45 over 48. Yes, okay. And then taking the inverse sine of both sides, this will be inverse sine of the ratio 45 over 48. There. Let's stretch that. Okay, so this will now be just X is equal to arc cosine of the ratio. So the computed value for the computed value for this arc cosine 45, we have 20.36. 20.36 413481. This will be in degrees, and X is rounded to 20. Let's verify. Yes, it's 20 degrees. Let's proceed to number 6. Here is number 6. Find the measure of the indicated angle to the nearest degree. Okay, examining the diagram, we have the question marked angle. This will be marked X. And what we have is the hypotenuse 44 and adjacent side 41. So again, the given data suggests we shall use cosine. So here's the solution. We shall use cosine of X. That's equal to the ratio of 41 to 44. There. Adjacent over hypotenuse. Now taking the inverse cosine of both sides, this will be equal to inverse cosine of the ratio 41, 44. And we elongate that X box. And we have the next line, just X. This will be our cosine of the ratio 41, 44. There. And angle X will be the ratio, inverse sine of the ratio, 41 to 44, we get like 21.27, 996647 degrees. There. And then rounded to the nearest degree, this will only be 21 degrees. And this is our answer. Okay, let's verify. Yes, it's 21 degrees. Okay, so let's continue with 7. Clear the screen. We're doing number 7. Here is number 7. Okay, let's examine the diagram. The same instruction, find the measure of the indicated angle to the nearest degree. Okay, what do we have here? The angle X is the one with a question mark. Okay, adjacent side to that angle X is the 8, and 11 is the side opposite to that angle. All right, so what we have is the opposite side and the adjacent side. This suggests that we shall use the tangent function. So in our solution, we will have to consider tangent of angle X. That will be opposite side over adjacent. So it's 11 divided by 8. And that's it. We shall use arc tangent of x is equal to arc tangent of the ratio 11 to 8. There. And we now have, in the next line, we have x is equal to arc tangent of 11 to 8. There. And what do we have after computation? This will be inverse tangent of 11 over 8. We have 53.97 26266 1. So this is in degrees. And then rounding it to the nearest degree, this will become 54 degrees. And that's it. This will be our answer. So this will be our answer. Okay. All right. And so let's verify. Yes, it's 54 degrees. Let's continue with number 8. Let's have number 8. Okay, here's number 8. Our angle with a question mark is over here. There. We're supposed to find the measure of that angle in degrees. Okay, what do we have as sides? We don't have the hypotenuse. So we have the adjacent side with the measure of 18. We have the opposite side with a measure of 19. So definitely we will use the tangent function. Opposite side divided by adjacent side. So in our solution, we'll be using tangent of x. This will be equal to the ratio of 19 to 18. There. And then taking arc tangent of both sides, this will be equal to arc tangent of the ratio 19, 18. There. And so our angle x, this will be arc tangent of the ratio 19, 18. And x is computed. X is equal to inverse tangent 19 to 18. All right, we have something like 46.54. 81577 degrees. And this will be rounded to the nearest degree. This will become 47. There. And this is our answer. Okay, so let's verify, find out. Yes, it's 47. It's over here. There. All right, so let's clear the screen and proceed to number 9. Let's have number 9. Okay, here's number 9. And examining the diagram, our angle will be this angle over here. Find the measure of that angle. We have adjacent side 46, opposite side to that angle is 120. And we don't have hypotenuse. So that means, or that suggests we shall use tangent. Okay, so we shall begin using the tangent function. Tangent of x is equal to the ratio 120 over 46. There. Opposite over adjacent. All right, and we now have arctangent of both sides is equal to arctangent of the ratio. There. And then we elongate the text box there. And next line will just be x is equal to arctangent of the ratio 120 and 46. All right, so computed value will be arctangent 120 is to 46. We have 69.02650658, and this will be in degrees, and rounded to the nearest degree, this will only be 69 degrees. There. And that's it. This is our answer. Let us verify and check it out. Yes, it's 69 degrees. All right, so this is correct. Let's continue with the last number. This is number 10. Okay, here's number 10. Examine the diagram. This is the angle X. And we have the adjacent side measuring 23, opposite side measuring 45. There is no hypotenuse. So we only have adjacent and the opposite side. And that suggests the tangent function. So we shall use the tangent function for the solution. So tangent of x is equal to the ratio of the adjacent, ratio of the opposite to the adjacent. So it will be the 45 divided by the 23. There. Okay, that is tangent. And this will continue like arctangent of the tangent is equal to arctangent of the ratio 45 and 23. There. And we have angle x. This is equal to arctangent of the ratio 45, 23. There. And the numerical value will be inverse tangent of 45 to 23. And we have something like 62.92791976. And this will be in degrees. Rounded value will be the rounded value is 63 degrees. There. And let's check and verify. Yes, it's 63 degrees over here. You can see the final answer over here. There. Okay, so this will be all for our finding angles in a right triangle. And see you later for other topics. Okay, see you later and God bless you.